In Grimes County, Texas, ground is breaking on a 100 million square foot semiconductor manufacturing space called Terafab. To picture that footprint, imagine 35 Apple parks, or 6 entire Manhattan islands consolidated under a single industrial umbrella. The financial commitment matches the physical footprint. It begins with an initial $16.8 billion investment and is projected to scale up to $119 billion. The architect behind this project is Elon Musk, and he is building at this scale to break through a massive silicon wall. Current global semiconductor output satisfies only 3% of the future computing demand required across his companies. This diagram illustrates the bottleneck. Every piece of his future ecosystem is starving for processors. Scaling human-grade robotics for Tesla Optimus takes over 200 million AI inference chips a year. xAI's Grok requires gigawatt-scale computing clusters. SpaceX needs radiation-hardened silicon for orbital compute, and the Cybercab fleet demands low-latency edge processing to run autonomous transport grids. Musk is attempting to assemble a self-feeding industrial loop, owning everything from raw energy generation to space compute. It is a brute force industrial solution to an existential resource scarcity. Futurists classify civilizations using the Kardashev scale, where a Type 1 civilization has mastered its home planet's resources and operates in total unified planetary harmony. There is an aggressive push to expand humanity into outer space, but giant extraction projects like Terafab threaten to leave behind a depleted, fragmented home planet. This creates a direct contradiction, the Type 1 paradox. We are trying to build advanced futuristic societies on top of a decaying ecological foundation. Depending on heavy resource extraction to conquer the stars actually anchors us down. It keeps humanity operating as a primitive, fragmented Type 0 civilization, bound by ecological exploitation. Scaling as a civilization requires a shift in industrial philosophy. Sustainable growth relies on harmonized, regenerative infrastructure, not the brute force of massive factory expansion. The current blueprint is built on an extractive model. It operates across divided geopolitical borders, locking vital computing power inside corporate-owned silos. Operating megafactories under this model takes a massive physical toll, draining local water tables and pushing regional power grids to the brink of collapse. This physical extraction is fueled by a specific economic engine. It relies entirely on the pursuit of endless capital gains within competitive, speculative fiat markets. The extractive model is a self-terminating loop. It accelerates our technological progress by actively consuming the planetary foundation it rests upon. The alternative blueprint is a regenerative model. This approach prioritizes positive return eco-factories and a zero-waste industrial philosophy. This flowchart illustrates the Kalundborg symbiosis in Denmark, a premier proof of concept for circular eco-industrial parks. Inside this park, the industrial byproduct of one facility acts as the vital raw material for another. Zooming out from individual parks, entire European smart cities are beginning to deploy quantum-managed energy grids. By utilizing quantum classical hybrid algorithms to perform real-time load balancing, these systems are reducing urban grid energy waste by up to 30%. We are also seeing the deployment of carbon-negative data centers. These hubs use algae bioreactors to capture emissions, and they route their excess thermal heat directly into local hydroponic agriculture. All of these are active, real-world signals, proving that our industrial compute loops can be engineered to heal the biosphere. For technology leaders, mastering vertical integration is no longer sufficient. It must evolve into total ecological integration. Controlling an entire supply chain becomes a massive strategic vulnerability if that chain degrades the exact biological systems it relies on to function. The resource demands of planetary-scale AI will soon force a global economic realignment. Speculative, debt-driven financial models struggle to manage the finite physical assets required for computing, leading to extreme market volatility and resource hoarding. To maintain stability, we require an economic system built on transparency rather than speculation. Transitioning to unified digital currencies backed by tangible gold and managed by transparent quantum grids creates a system designed to prevent inflation and ensure resources are distributed where the grid needs them most. Moving from profit-driven volatility to asset-backed quantum stability is the mandatory prerequisite for a world powered by frontier AI. Building a Type 1 civilization is not an engineering problem that can be solved by brute forcing larger factories or extracting more resources. The true benchmark of an advanced civilization is collective wisdom. It is the ability to exist as a unified, borderless species in eternal balance with nature. To reach that stage, humanity has to abandon its divided mindset and achieve planetary harmony right here at home. We spend a lot of time looking outward, calculating the rocket trajectories needed for multiplanetary exploration. But that external ambition means nothing without internal stability. We cannot conquer the stars and achieve Type 1 status until we first prove we can live in harmony on Earth.